The advancement of data science and artificial intelligence often makes us believe that we are dealing with entirely new concepts. But the truth is that the mental mechanisms behind the algorithms we use today were forged many centuries ago. Hello, I am Antonio Mello's AI avatar, and this is another episode of Data Insights by Design. Today, we are going to explore how two philosophical tools from the past helped build the foundation of today's technology. For almost 2,000 years, the way the Western world organized thought was dominated by Aristotle's system of logic. He documented this method in a collection of treatises that later became known as the Organon, a Greek word meaning instrument. The Organon worked essentially as a syntax manual for human thought. Its goal was to create strict rules to ensure that an argument was structurally free from fallacies. At the heart of this model is deduction, a form of reasoning that starts from general and universal rules to reach specific conclusions. Think of the classic syllogism. If we assume as a premise that all men are mortal and that Socrates is a man, then the conclusion that Socrates is mortal is not a statistical probability. It is logical determinism. It is top-down reasoning. The Organon was a brilliant tool for structuring reason. However, it had an intrinsic design limitation. Deduction does not generate new knowledge. It merely reveals and organizes what was already embedded and implicit in the original premises. Aristotle did consider some form of induction in his method, but it was a primary type of induction, focused on simple enumeration and on quickly establishing universal principles. This limitation, associated with the creation of new knowledge, became unsustainable when we reached the scientific revolution. Humanity needed to expand its boundaries, and that was when Francis Bacon proposed a system upgrade. In 1620, he published the Novum Organum, a new instrument. Bacon argued that Aristotle's logic kept us trapped in theoretical debates, operating only with ideas without testing them against reality. For Bacon, the mind needed a new method, one focused on the real world and free from biases. To move forward, it was necessary to observe systematically, conduct rigorous experiments, and collect data from nature. Modern induction was born. The path started from the massive collection of raw data and isolated particular cases. Then, from the accumulation of this evidence, it became possible to infer a new general law or theory. It is bottom-up reasoning. It is not focused on organizing what is already known, but on discovering what is still unknown. And how does this difference between the deductive rigor of the Organon and the inductive exploration of the Novum Organum impact our corporate and technological reality? The answer lies in the very architecture of modern software. Traditional programming and symbolic AI operate in Aristotle's field. When we write code with explicit rules such as, if this happens, then do that, we are applying the pure logic of the Organon. The system deduces outputs by strictly following the premises defined by the programmer. On the other hand, machine learning and neural networks operate in Bacon's field at a scale he could never have imagined. We feed these models with terabytes of raw examples. Say, from this data, the algorithm induces statistical patterns, creating correlation rules that were never programmed line by a human being. What we see in contemporary data science is not the replacement of one method by the other, but the hybrid architecture required to deal with complexity. We start from Aristotle to structure with certainty, and we use Bacon to scale discovery. This brings us to one final reflection. If the Organon and the Novum Organum brought us all the way to the foundational AI models we have today, what will be the next great instrument of human thought? Leave your opinion in the comments. It is important to us. See you in the next episode of Data Insights by Design.